Hello everyone, this is LS in the S team because we are all from life science. And our team is Morozov Nikita, Sokolova Daria, and Suleimanov Shakir. So we have been working with the flu shot dataset, and the main problem is that despite the availability of the vaccines, the big portion of population remains unvaccinated, and there are a lot of statistical data about it due to the World Health Organization and other organizations. And Actually, it induces the healthcare costs, and this is the big problem. And Public health organizations need to identify the key factors which influence the people's decision about the vaccination. So the main goal of the project was to develop a machine learning model to predict whether an individual will receive a flu shot or not, based on different features like social, demographic, and so on. And another important goal is to identify key factors which influence the people's decision. So why the machine learning? Because it's actually very good at the prediction, the probability of the individual receiving the vaccine H1N1 and seasonal vaccine, for example, which we have been working with. And it may lead to the cost reduction of the whole vaccination program, which is a good benefit for the healthcare system, and improve the strategy due to the identifying the important features. So our initial data set was like this. It had 36 features, and there were two targets, H1N1 vaccine, 0 or 1, which is no or yes, and seasonal vaccine, the same target. So our working pipeline was to identify, first of all, the missing values and fill them. After that, exploratory data analysis, feature engineering, and training a set of models with the grid search to identify best hyperparameters for H1N1 and for seasonal vaccine prediction. First of all, we have identified the features which contained a lot of NAs, and we simply dropped this feature off because so we had a cut off, which is the red line here, because we believe that working with features that mostly contain on the predicted values is not a very good idea for building a prediction model. So we dropped them off, and we performed the KNN imputation for other features for their missing values. We think that actually the KNN imputation takes into account the relationship between features, while simple statistics like mode or median just use the global summary of a single feature. Further, we have proceeded with the exploratory data analysis. Here is the distribution of numerical features, and we have tried to find some intuition on the balance of the feature values. The same was performed for the categorical features. For example, here we can see that for the race, there's a huge imbalance towards the one particular class, which is not very good for the model. But first of all, we will try to build an initial model with the basic features, and then we will see how we can improve it. Also, we have calculated correlation matrix for numerical features. We can see that the highest correlation coefficient, Spearman's correlation coefficient, is around 0.158, which is not very huge. Additionally, we have calculated the variance inflating factor to detect the multicollinearity, and this also gives some intuition about which features could be further excluded from the analysis if the initial model will be not very good. And here is the target balance. We see that, for example, for seasonal vaccine, there is a more or less balanced target value, but for the H1N1, the target is unbalanced towards the class 0, which is not vaccinated. So after the manipulations with NA values and exploratory data analysis, we have a data set which contains 31 features. So we dropped 4 features, and one feature was responder ID. Of course, we didn't include it into the model prediction, model construction. And we got some intuitions about which features could be excluded from the further analysis, and we will work with this information and improve our initial models with it if it will be needed. Actually, here's a slide about the model training. This is a model based on all those features which have been shown previously. Of course, we did the basic pipeline for the scaling of the features using standard scalar, and we converted all categorical values into the one hot encoding, like get dummies in the pandas, so it's like 0 and 1 for the model to be able to work with the features. And here are the results. We have used a set of models: logistic regression, random forest, KNN, CatBoost, XGBoost random forest, and Gaussian naive Bayes. And these models were run for the grid search. We have identified the best hyperparameters for the models, and we have calculated the AUC scores for the training performance and for the test. And here you can see with the green color the two best models, which were selected like the best due to the performance on the area under curve score. The same was performed for the seasonal vaccine, and you can see that the same models have the best performance. Again, it's the CatBoost and XGBoost. And actually, it might be due to the fact that we have more hyperparameters for these particular models, but actually it was like more or less okay. So feature importance here, we have calculated sharp values for only two best models. So it's in both cases, it's CatBoost and XGBoost. And we can see that, for example, on the top, there is features like doctor recommendation and opinion about vaccination effectiveness. So these features are very important for the people's decision about the vaccination, and the same was performed for the seasonal vaccine. So here are also the SHAP values for the seasonal vaccine. And this is the final slide. Thank you for your attention. Here is a short summary and the link to the GitHub repo where you can find the code and the information about our work. So thank you very much.